Objectives for 2.5. Recognize graphs of common functions. Use vertical shifts to graph functions. Use horizontal shifts to graph functions. Use reflections to graph functions. Use vertical stretching and shrinking to graph functions. Use horizontal stretching and shrinking to graph functions. Graph functions involving a sequence of transformations. Yeah. So basically, number 7 is all these, except doing it more than once at a time. So we are getting really wild here, but we also did all of this in Algebra 2, right? Yes, all year, in fact, because we did it over and over as we got to different parent functions, right? Okay, so hopefully you guys are really good at this. I'm pretty confident that you are, because I was your teacher. Okay, so let's talk about some parent functions. I'm going to just draw you a bunch. So I'm going to go ahead and draw my X and Y axes so I can already have these here. I think I'm going to end up drawing you 12. Some of them we did in Algebra 2. Some of them we did not. I can tell how excited you are. I need you to calm down a little. Okay. Give me just a second to draw these X and Y axes for you. Yep. I mean, yes, ma'am. How long is she here? Did you know she was coming? Okay. Surprise. Okay, ready? What is it? What is this equation? So it's linear. And the equation? Even more basic than that, right? Just y equals x. Okay, you're fine. What about this one? Oh my gosh, one day I'm going to teach you how to say that right. One of these days. Parabola. And if you want to get technical, you were saying parabola. Yeah. It's almost like the word adequate. Yeah. A person yesterday. It's fine. It's fine. Okay. And what's the equation? Y equals x squared. So what I was saying is if you want to get technical, the picture is a parabola. The equation is a quadratic. Okay? I'm okay with that, though. At least you knew something. What about this one? Absolute value. And the equation? Okay, good. I have to tilt this one. I'll tilt it back in a second when I'm done drawing it. I'm going to go ahead and it's not, but it's a good guess. Okay, there's that then. It's related to that one though. What you said a minute ago. It's related to that though. What's the inverse of a logarithm? Starts with an E. Yep. Okay. So this one is which one? Growth.
Miss Kingston?
Yes, sir.
Do you have Peyton?
I do, and she's going to come in a second when we finish the lesson, if that's okay.
Absolutely.
Thank you.
All right, bye-bye now.
Bye. Oh, my goodness. So this one's exponential growth, this one's exponential decay. What's the equation? Y equals b to the x. Okay? y equals b to the x. And that's true for both of these equations. If it's growth, b is greater than 1. Remember that? What is it when it's decay? Close. And greater than 0, right? Greater than 0 and less than 1. So between 0 and 1. Okay? Okay with that one? How about this one? Remember? Almost there. We're almost there. Y equals the square root of x. Not quite. What is it? Yeah. Yeah. So that's cube root. And which one's this one? Yes. So y equals x to the third. And this one? Now. Excellent. So this is y equals log. We'll go ahead and write base 2 of x. It could be base 10 or base e or base whatever, but we'll just go and write a 2. Okay. How about this one? Oh, you can't see it, sorry. It's just rational. Yeah, y equals, what's the equation? Nope. Bottom. 1 over x. Okay, then there's this one, which you're not going to guess, and I don't mean that disrespectfully. Correct. Don't whoa me as if I was a horse. It is a piecewise function, but it has a specific name. That's a good guess. It's actually called an integer. So y would equal some integer. And the last one, you may be able to guess. It is a horizontal line, but it's called a constant. So y would equal some constant, like 2 or something like that. Okay? In this one, y equals every integer, right? 0, 1, 2, 3, 4, 5. And it could even go the other way. I just didn't want to draw any negatives. Okay? So, which ones of these are you very familiar with? Well, we actually did that one in Algebra 2, just so you know. Okay? We did this one. We did this one. We did this one. We did this one. We did this one and this one. We did this one. This one. Well, we even did rational. Yeah, didn't we? Yeah, so just this one. Yes, it is. They're all fun. Okay? What? You don't even know. Yeah, that's the difference. Okay, so here's what we're going to do, okay? To talk about, because I could give you equations to talk about all of these individually, and I'm just not going to do that because we've already done that already, okay? So if it's okay with you, let's talk about this. F of x equals plus or minus a parenthesis plus or minus b x minus h squared plus k. Okay? That's what we're going to talk about. What parent function is this? Or what parent function would this be a transformation for? Quadratics, right? That's a parabola. It's quadratics because this is squared. It's the one we worked with most often. You also worked with it in Algebra 1, so you've been dealing with it for a while now. Okay? So I want you to tell me about these two plus and minuses I put there. Having a positive A, having a negative A, or a negative B causes a reflection, right? So a reflection for this first plus or minus, it's a reflection over what? And then for this one? Correct. Reflection over the y-axis. For H and K, what kind of changes do those cause? So the thing they have in common is it causes a shift, right? So these are shifts. And remember, what's the most important part of that word? The F, right? The F. We have to remember the F. If we don't remember the F, if it's a different word, right? Okay. The H is also important, but sift is an appropriate word, right? Okay. So if we're talking about the H means horizontal, but it is inside, right? The parentheses. And so it's going to move opposite of what we think, right? Or backwards. Or opposite of what we think. So if it says negative 2, it's going to move right 2. If it says positive 6, it's going to move left 6. Okay? The K actually stands for vertical, even though that's a C, right? And it's outside, so it's going to move exactly how we think. Then we have A's and B's, right? A's and B's. A's and B's are going to cause a stretch or a shrink, but we also used to say compression. Okay? A is where? Outside. So it's going to cause, depending on what it is, either a stretch or compression, but it's going to cause a vertical change, right? A vertical stretch or vertical compression. B is on the inside, so it's going to cause a horizontal change, either a stretch or compression, depending on what it is, right? Okay, so let's think about this. If A is 2, that's causing a vertical stretch, S-T-R-E-T-C-H, by a factor of 2. If A is 1/2, it's causing a vertical shrink by a factor of 1/2, right? What if B is 2? If B is 2, it's a horizontal shrink by a factor of 1/2. Yeah, because it is the reciprocal, right? It's inside, so it's going to be different than when we think. Over here we said backwards or opposite of what we think. When it's a multiplier, it's the reciprocal of what we think. Okay? So it's a 2, so it's going to be a shrink by a factor of the reciprocal of that multiplier. Okay, so what if b is 1/2? Horizontal stretch by a factor of 2. Okay? Everybody okay with that? So the last part of this, graphing functions involving a sequence of transformations. If I gave you some sort of long equation, you could totally graph it and go from there, right? So the thing that's going to be different in the homework, though, is it's going to say here, it's going to give you that function, that graph. Okay, there's no equation that goes with that graph, is there? But it's going to say, oh dang, I didn't write that. Okay, hold on. F of x minus 3 plus 4. It doesn't give you the exact function. It says take the function that's there and say x minus 3 plus 4. So what is it asking you to do? To the right 3 and up 4. So each point I go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So it's right here when I move it right 3, but then I need to move it up 4. Each point, right? 1, 2, 3, 4. 1, 2, 3, 4. I didn't think this out very well, so please forgive me, because it's going to go through our notes, isn't it? Maybe not. So that the end function is actually up there. You see what I'm saying? Because if I said to you, f of x equals negative 2 x minus 4 squared minus 3, you know that's a reflection of the x-axis, vertical stretch by a factor of 2, horizontal shift right 4, vertical shift down 4, right? You would know that. This is what's a little different in this book's homework, is they don't always give you the exact equation. They give you a graph and say, what does the new graph look like if I tell you to do it this kind of way? Does that make sense? Are there any other questions about any of the other objectives for this section? You good? Okay, peace.